Hi everyone, welcome back to another product review video, and this is video 2 in our mini-series looking at GPR options from Leica. Right, so yeah, we're back with Shane for a second video, and this time we're going to be looking at the Stream DP and the Stream Up. So yeah, this Stream DP, what's it all about?
It's so the Stream series of radars are mass array systems.
Okay.
So these contain a number of antennas within them, and therefore mass data capture really.
Okay.
As you can see from the system, it's this one's nearly just over 1 meter wide.
Yep.
And it contains 30 antennas within it.
Okay.
In what we would call dual polarization. So we now have antennas, the systems in the DS2000 and the DSX that we looked at have antennas in one polarization,
Okay.
a single polarization, meaning we need to undertake a grid over the site.
Right. Okay.
North, south, east, west,
yeah.
or longitudinal, transversal. This system actually has antennas in both polarizations, so a dual polarization system, meaning data capture is sped up enormously,
Okay.
and the level of data and the clarity of the GPR data is far greater, because we've effectively got an antenna spacing of 50 mil.
Yeah.
So it's like going up with a single antenna system, coming across 50 mil and doing another transect and another
Okay.
transect and another transect. So level of data from these is absolutely incredible.
Yeah. So whereas with the other ones, like you say, we'd have to do a grid. In this, we can just go up, come down, and it's doing what that was doing as a grid, but just in one pass.
And you can imagine on a larger site,
Yeah.
the time saving for something like that is incredible.
Yeah.
So, a lot of the guys who use radar systems are, they're working within traffic management and things like that. There's a large cost to those sorts of things.
Yeah.
So to be able to use some of these systems without the requirement for traffic management or anything, the Stream Up that's on the back of the system, negates the costs there for the client.
Cool. So again, we are GPS positioned on this, controlled through tablet and post-processed data.
Post-processed again through IQ maps. But again, when we talk about positioning, it's GNSS, it's total station, so we can put a prism on here, or again, we can do grids. So positioning is really important. And the same with the Stream Up. Again, we can use GNSS, we can use total station.
Yeah.
We've also got the ability on that system to add an APS system, accurate positioning system.
Okay.
So that is an IMU, which obviously takes pitch and roll into account with a GNSS. So where we're working in GNSS denied areas, that is able basically to keep on going. And then within the software, we can actually post-process our trajectories by adding Rhinex data in as well. So makes it absolutely spot on.
So lots of options there with that. So also with the previous systems, we talked about, yes, you can post-process, but you can also sort of mark as you go. Is that something that you would do with this, or is it more?
So you wouldn't typically mark with these sort of systems, because we've got so many antennas across. Where is antenna number 17? In our HH orientation, for example, whereabouts is it? But the software's slowly being developed to enable us to do that. So you can see a mark at the back here. So coming in the future, we'll be able to basically mark out with this system as well.
Okay, cool. And obviously, like I say, we've got a lot bigger chassis, 4 sets of wheels. Well, no, actually, sorry, 6 sets, because there's 2 on the back here. Do you have to run this setup, or can you run just the 4 outers, or
so
the maneuverability is what I'm getting at?
I've got those wheels just on at the moment. Typically, these larger wheels cover all sort of terrains. So genuinely, when this system was first launched, I took it to a farmer's field, proper muddy farmer's field, and pushed it across the field. Good data and usability across that. So these smaller wheels, effectively, these larger wheels would come off. If you want to take that one off that side, just press it in the centre. Okay, and this then offers some manoeuvrability to the system. So if we're working in a city centre environment, and we're in and out of pedestrians and street furniture and those sorts of things, easily manoeuvrable and really light to push around as well.
Okay. So, and the encoding then is on all four wheels if you can remove
Correct.
them.
Yeah.
Okay.
Exactly. Yeah.
So you, by running less wheels, you don't,
no, you don't
diminish the data
no,
or anything
absolutely
like
not.
that. So,
No.
Okay. No, that's cool. Again, battery operated for both the antenna and the tablet.
Yeah. So obviously the tablet has its own battery within it, and then in the system itself, as you can see, we've got two Jeb 364 batteries, which are the same as go in the RTC. A pair of those batteries will last you probably, a day and a half, almost 2 days on site. So very low power usage from the radar itself.
You'd assume a big system like this would need big power demands. But
no, not at all. Just a couple of those, and obviously then, the power, is on the tablet then within the inbuilt battery on the tablet.
Cool. So also deep penetration, is that? Yeah. So I think
it's been one of these things that people have picked up on. So if we were to go through acronyms, radar itself is an acronym. So radio detection and ranging. Stream is also an acronym.
Okay.
Subsurface tomographic radar for extra wide area mapping.
Okay.
Rolls off the tongue.
Yeah.
And the predecessor to this was the Stream C.
Yeah.
So that C actually stood for compact.
Okay.
And when I say that to people go, crikey, that was a massive unit. How can you call that compact? Well, it was a compact array system. So that had 34 channels within it. So you think, one of these systems or a comparable radar that has one or two antennas in it is, 400 to 500 mil wide.
Yeah. Within
a antenna box a metre wide, you've now got 34 antennas.
Yeah.
So you can see why they called it a compact array
Yep.
system. Yeah. So DP for this, is deep penetration, and that is driven by this EST technology. So this equalised scramble technology. So what that's doing is it's using effectively what would be noise, and it's able to interpolate that and bring that back, which enables us to see deeper into the ground.
Okay.
So it's a 600 megahertz antenna, and in fact around here we've had data of 5.5 6 meters with a 600 meg antenna, which to me is absolutely crackers.
So in similar conditions or on the same site, this is going to get utilities a lot deeper than
one of those or a comparable radar system. Absolutely. I would say this probably sees deeper than a lot of things, other than something like the Chaser XR, which we'll talk about in the next one.
Cool. So obviously we've mentioned the predecessor to this, the Stream C. Now one of the things with that, it was a big unit, and moving it around and getting it to site was a bit more fun and games. Whereas this system, we'll show some videos in a minute how it all goes together, but it breaks down.
It's evolution, isn't it? We're surveyors. Okay, our predecessors as surveyors were carrying car batteries to the top of mountains and putting an instrument on top of a trig point. So that's where we develop things. So the Stream C, for example, fantastic data and still gives good data, and there's lots of people still using it. That system weighed, I think, about 95 kilograms.
Yeah.
This system is less than half the weight. So this is about 40 kilograms as a system. And as we'll see, taking it apart is really straightforward, and it goes in the back of a standard car or whatever else. So manual handling wise, one person into the back of a car.
So it is very much that, a one-person user, whereas the Stream C more was just for the manual handling, was a two-person job. So it's an interesting bit of kit on that front as well, from a business perspective, let's say.
Yeah, absolutely.
So, no, that's cool. No, so that's perfect. So that's the Stream DP. We'll have a look at that in action in a minute. So should we jump over to the Stream Up and see what that's like?
Have a look at that back of the car.
Cool. So here we go, the Stream Up. A lot bigger unit than we've seen so far.
Yeah.
So tell us about this one.
Yeah, so again, Stream, as you remember, is an acronym.
Yep.
Subsurface tomographic radar for extra wide area mapping, and the Up is actually for utility patrolling. So this system is designed for, I suppose, highway utility mapping, typically. So it's 1.6 meters wide. sits on the tow bar of the vehicle, and uses the tow bar electrics to power the system. So no other batteries required for it, and just runs off the engine, I suppose, or the battery of the car itself. In this sort of position, this is in sort of acquisition mode, so lowered to the ground in effect. But what we can do is we can raise it up and we can drive to site. So we could load it up here. We could drive to our site. We can initialize the APS system with the IMU, and then we can lower this to the ground and we can go and collect our data, just driving up and down the highway.
So, yeah, obviously this is moving on the back of a car. What sort of speeds can you do with this? Because obviously with the others it's walking speeds.
Yeah, typically. So one thing I didn't mention, I suppose, is the DP can actually, there's a tow attachment for that as well. So that system can be towed, and we can go up to about 10 miles an hour with that, you know, so across fields, those sorts of things. This system, I mean, we can collect data up to something like 90 odd miles an hour. But slower and lower to the ground is going to give us better data.
Slower and lower,
so up to about 40 mile an hour is our optimum sort of speed that we can collect. So you see that covers most sort of carriageways, highways. And then, you know, if we can go slower, great. If not, then we can speed up. And basically there's a slow decline, I suppose, on the quality of the data we're getting. But it depends what we're looking for again, you know. So if we're just looking for, you know, a culvert crossing a road, you know, on the motorway, we might be able to see it, you know, through the data there, travelling at, you know, 60, 70 miles an hour.
Yeah, but for your normal town or roadway, this can be done with no traffic management. You're just going with the traffic that's already there on the road. And maybe if you were doing a motorway, for example, you might want some other form of
a buffer vehicle or something like that, and you might be working night shifts or whatever. You know, we've got to think safety, and even these systems, you know, they lend themselves to safety. So we've now got operatives in a vehicle driving down a highway. I've used radars where I've been up and down the carriageway, you know, in between, you know, breaks in the traffic to try and find something, or worked within traffic management. And what are you protected by? A line of cones. That's all.
I've had a guy with a stop go board.
Exactly. And you've had somebody drive into the, you know, the traffic management managed area. You know, because it's confusing for the driver. So as a safety point of view, to have it on the back of the vehicle, out of the way, you know, you can be in the cab in a place of safety, then that's all good.
So all controlled from the cab, or all sort of on board?
Yeah, so linked to a PC via a Wi-Fi connection. The system can also be hardwired as well, so you can have a wired connection to it if required. And then just all connected from the front, really. All the data's saved on here, and then we just download it via the USB. Which is a 30-second to a minute thing at the very end.
Yeah, and then again post-process through
IQ Maps.
Similar.
So we'll have a look
software,
at that later as well.
Yes, but between all the streams, sort of. Well, actually, in fact, all the GPR can all go through that.
All the GPR data can be run into IQ Maps. So you've got one piece of software that all your data can be run into, and you know, processed, filters applied, and then you can draw your utilities on, obviously, and export out from there.
So obviously you've highlighted a bigger array than the DP. That was how many antennas?
So there was 30 channels in that, 600 megahertz.
Okay.
So 30 channels at 600 meg with EST technology. So this system again has 30 channels, but again dual polarized, so antennas in both directions, both HH and VV.
Okay.
But this has dual frequency as well. So this has 600 megahertz antennas and a lower frequency of 200 megahertz. So there's a balance there between looking for stuff again in the shallower depths and a lower frequency to penetrate the ground a bit deeper.
And I guess that also then helps to a certain extent with the speed element, the fact we're moving quicker than we are with some of the other handheld or hand-pushed units.
Absolutely. Yeah. So it's, as I say, on the back of the vehicle, and you know, these are in kilometres, but we can travel up to 110 kilometres an hour with the system.
A fair old speed.
Yeah.
No, that's cool. Okay, so I think again that's a nice overview of this system. So we'll get them both out and see how they work, have a look, and perhaps have a look at the data at the end.
No problem.
So there we go, that's the Stream DP and the Stream Up. If you've enjoyed this video, give it a thumbs up and a subscribe. We've got a third part to this video series coming. So yeah, so the first video will be linked up here and some of our other product review videos, and we'll catch you all on the next one.